Hi, welcome to the Plasticity for Beginners training. This is a unique opportunity to learn the basics of solid modeling in plasticity. During the training, we will discuss key issues that will allow you to quickly master basic operations and start creating your own 3D models. Thanks to this, in a relatively short time, you will be able to move freely in plasticity. Plasticity is an innovative 3D CAD system that uses direct modeling methods. This means that all modifications are made directly on the 3D model, making the creation process fast and efficient. This approach works perfectly for both product modeling and conceptual modeling. The goal of our course is to introduce you to working with plasticity so that you learn the basics of this software and can create simple 3D models on your own. To download Plasticity, visit plasticity.xyz and click Pricing. You can choose between a 30-day trial version or one of the available paid versions. Plasticity offers a lifetime license with 12 months of access to updates. This means that for the first 12 months after purchase, you can download and install all updates. After this period, you can extend access to updates or use the program without further updates. If you choose the paid version, use the discount code DamianCADCAM during purchase. This code will reduce the license cost by 10%. And if you want to support the development of this channel, I would be grateful for any support on the Ko-fi portal. And you can find more plasticity tutorials on my second channel, Start 3D Modeling, and I encourage you to subscribe to that channel. Links can be found in the description of this video. The video description also includes timestamps for key moments. Let's get started. In this lesson, we will briefly discuss the plasticity interface. We will cover some basic issues, and later on, during further work, we will discuss matters that will be needed at a given moment. As for plasticity, as you can see, the area is divided into 3 sections. On the left side, we have a panel. Here is the workspace, and on the right side, we also have a panel. Regarding the left panel, this is where the geometries we will create will appear. The right panel is more of an informational panel, and we will return to that panel later. What interests us the most is the workspace area, and this is where we will create 3D models. In this workspace area, as you can see, we have a grid and coordinate system axis, the x-axis, the y-axis, and the z-axis. As for this grid, we can specify the dimensions of this grid and the units we will be working in, and we do this in the menu. To access this menu, expand the menu under the letter P and navigate to Preferences. Regarding the most important preferences, these preferences relate to navigation and the size of the grid. For navigation, select the default plasticity navigation, and it works in such a way that by scrolling the mouse wheel we zoom in and out of the view, and by pressing the right mouse button we can move an object in the workspace. Next, go to the Grid and Units section, and here we specify the units. I choose millimeters. Here we specify the grid size. I entered 500 millimeters, as I probably will not design larger elements, and here we determine the distances between these thicker lines. So, the small squares are spaced 1 millimeter apart, while the larger squares are 10 by 10 millimeters in size. This can be useful in some cases. There is also a note that plasticity needs to be restarted to confirm these changes, so if you made changes, restart plasticity. Now, how can this grid be useful? We have something called Snap to Grid here. If we check this, when creating geometry, it will snap to the grid every 1 millimeter. Here, I will choose to create a rectangle. For now, you don't need to do this, as this lesson is more informational and you may not see it clearly, but the cursor is snapping to the grid every 1 millimeter. Now, I will start drawing the rectangle at the coordinate system origin and pay attention to what the dimensions of the rectangle will be. These dimensions of the rectangle change in even millimeters because I have Snap to Grid enabled. So, in this way, I can specify the exact dimensions of the rectangle. This is not the only way to specify exact dimensions for geometry, but if we want to quickly create a shape that has roughly specific dimensions, this Snap to Grid feature can make things a bit easier. As for this Snap to Grid, we can change it. We can, for example, snap every 5 millimeters. Now pay attention to the dimensions of this rectangle. They will just be snapped every 5 millimeters, and we can increase this up to 100 millimeters. I will return to 1 millimeter here and for now I will disable snap to grid. Now I press escape to finish drawing this rectangle. Regarding such snapping, we also have snapping to different objects, to faces, to curves, and to edges, and this is also useful, and we will leave this snapping enabled. As for the basic issues related to the interface, we will finish here, and in the next lesson we will discuss the basics of navigation. In this lesson, we will briefly discuss navigation in the workspace. I will create a box here. I select draw a box, and as the first point, I specify the origin of the coordinate system. Here, the snap is activated. I click the left mouse button, and now I specify the second point of this cube. For now, I will do this without specifying dimensions, and now I add an extrusion. I click the right mouse button to accept it, and we have a solid here. Now, regarding basic navigation, we can zoom in and out of the view using the mouse wheel. By simply scrolling the mouse wheel, we zoom in or out of the view. If we want to move the view in the workspace, we press the right mouse button and move the object. As for selecting geometry, we have different selection modes. When it comes to selecting vertices, we currently have no vertices. Vertices are on flat geometries. If I create a rectangle here, for example, the rectangle has 4 vertices. Here I can select these vertices. Regarding edge selection, this is the mode where I can select flat geometries and model edges. Next is the selection of faces and areas, where I can select the model's faces or areas of flat geometry. Next we have the selection of solids, so here we can simply select solids. We can switch between these modes using the keyboard buttons sequentially. 1, 2, 3, 4. By pressing key 5, all modes will be active, and here we can select edges, faces, vertices, areas. All modes are active, but I prefer to use single modes and simply switch to what is currently important for me. And here we have a box, and by clicking on the faces of this box, we can align the views of the coordinate system planes. If, for example, we want to draw something in the top view, we can click on this face, and we will be switched to the top view. Now, if I press the mouse wheel, I can rotate the solid. By pressing the mouse wheel, we can rotate the view. This automatically disables the view on the construction plane, and here we have a button that enlarges the geometry. This can be useful if, for example, we zoom in too much or zoom out too much on the geometry. By clicking this button, we can simply display the entire geometry. And if some geometry is selected, for example, I select this solid, and now click this button, it will simply be enlarged to be displayed on the entire screen. And those were the basics regarding navigation, and we will regularly return to this in upcoming lessons. We will finish here and move on to the next lesson. In this lesson, we will move on to creating simple shapes. We will start by creating 2D shapes, which we can then use to create a 3D solid. Regarding these basic shapes, they are available in this menu. Here we have line drawing, spline drawing, circle drawing, polygon drawing, spiral drawing, and rectangle drawing. We will begin with drawing a rectangle. However, as you can see here, there are little arrows next to some commands. If you click on this command with the left mouse button and hold down this button, additional commands available under this command will appear. Now, to select a command, you just need to release the left mouse button over that command. Let's choose to draw a rectangle from the center. I'm pressing the left mouse button here, hovering the cursor over that command, and releasing the left mouse button. Now this command is active. We need to define the center point of the rectangle, and then we specify the second point. I have created a rectangle here, but at this moment I created that rectangle quite freely, and I don't even know its dimensions. If I wanted to determine the geometry with specific dimensions, I would have to approach this a bit differently. This rectangle is selected, so I will press the delete key to remove this rectangle. I will select this command again and place the center point of this rectangle at the origin of the coordinate system. Here, as you can see, dimensions are displayed next to the rectangle. If we want to create a rectangle with specific dimensions, we can, for example, use grid snapping and use a grid point here to determine the dimensions of the rectangle. we can press the Tab key, and now we can specify the dimensions of the rectangle. Here, as you can see, the length dimension of one side of the rectangle has been activated, so I will enter 100 millimeters here. I press Tab to activate the dimensioning of the second side of the rectangle. I'll enter 80 and press Enter to confirm. Now, this rectangle has defined dimensions. The length of this side is 100 millimeters, and the length of this side is 80 millimeters. Based on such a rectangle, we can create a solid. However, if you entered the wrong dimensions for the rectangle and would like to change them, select this rectangle, just select the edge of this rectangle and press the equal sign on the keyboard. Now we can again specify the lengths of the sides of this rectangle. For example, I'll enter 70, hit Tab, 120, hit Enter, and in this way we change the dimensions of this rectangle. As for selecting geometry in Plasticity, here we have modes for selecting geometry. Currently, edge selection, face selection, and solid selection modes are active. If we would like to switch to selecting only two edges, we simply click on this icon, and now we can select edges. For example, I can no longer select the area of this rectangle. The area of the rectangle in selecting is treated as a face, so if I want to select the area of the rectangle, I need to activate the face selection mode. Regarding these selection modes, we can switch between these selection modes using the keys on the keyboard. The key 1 is for vertex selection, key 2 is for edge selection, key 3 is for face selection, and key 4 is for solid selection. If you would like to enable all selection modes, press key 5 and now you can select vertices, edges, faces, and whole solids. However, in my opinion, it is more convenient to switch between individual modes, because if we want to select only an edge, we simply choose this edge selection mode and it makes it much easier to select edges since we won't accidentally select any other geometry. We have drawn a rectangle, now we will create another shape. We will create a circle. Select Circle Drawing, and here, just like when drawing rectangles, when I press the left mouse button, several commands will appear. Let's choose the command to draw a circle from the center. Now, to draw such a circle, we simply define the center point and specify the second point of the circle. Here I drew an arbitrary circle, so I'll press the Delete key to remove it. Now, I will draw a circle with a diameter of 10 millimeters. I will select the command to draw this circle, and I will place the center of this circle in the corner of this geometry. Here, as you can see, a snap appears that will allow us to place the center of the circle right in the corner of this rectangle. I will click with the left mouse button, and notice what happened here. Now, if I create this circle, press the Tab key, and enter a diameter of 10 millimeters, this circle was created in the XZ plane. I wanted to create that circle on the XY plane, but sometimes something like this can happen. I pressed Delete to remove the circle and select Circle Drawing again. Now I select the snap and notice how this snap is located. This snap is indeed in the XZ plane, and the circle will be created in such a plane. Now, as I change the cursor's position a bit, this snap has been rotated and the circle will be created in the XY plane. If we wanted to be 100% sure that this circle would be created in the XY plane, and we don't want to search for these snaps too much, we simply switch to the top view, to the view of the XY plane. Here, the plane from the top has been activated, and now we hover over this point. Here the snap has been activated. I click with the left mouse button, then press Tab, enter 10, hit Enter, and we have created a circle lying in the XY plane with its center in the corner of this rectangle. Why did I create this circle in this place? Because I would like the center of this circle to be offset from this edge of the rectangle by 10 millimeters, and from this edge also to be offset by 10 millimeters. Plasticity is not a parametric system, and it is not a system where we can specify distances through dimensions. Here we have to define the position of the geometry in a different way. In such cases, I do it in a way that I create geometry at some reference point and then move the geometry away from that point by a specified value. I will do it this way. In this case, select the circle, choose edge selection, select the circle, choose the move command, and we can activate this command by pressing the G key on the keyboard. While we are at commands, here we have a list of all available commands, and we can also activate such a list by pressing the F key on the keyboard. I press F and here we can type the name of the command. We can select a command from this list. Here we have the move command, which is available under the letter G. But this command is also available under this icon. I click here, and now we can specify the values of the offset of this circle in the X and Y axis. To move this circle simultaneously in the X and Y axis by 10 mm, we have fields here where we enter the offset values in the X, Y, and Z axis. On the X axis, I will enter 10, and on the Y axis, I will also enter 10. I clicked with the left mouse button somewhere above these fields to update the preview, and click OK here to confirm. In this way, we created a circle with a specific diameter whose center is offset 10 mm from this edge and 10 mm from this edge. This way, we can approach creating geometries in Plasticity which are to have defined dimensions and a specified position. We will finish this lesson here, and in the next lesson we will continue working on this example. Therefore, save this project. To save the project, we go to the menu, select Save As, then specify the location and file name, and click Save to save the project. In this lesson, we continue working with this file. Now I will show you how to create circles in the other corners of the rectangle. Of course, we could draw such circles and move them appropriately. However, we can also use the mirror command, which significantly simplifies and speeds up the creation of geometry. To add the mirror command, we first select the geometry we want to mirror, then we select the mirror command. This command is under this icon, or we can use the keyboard shortcut Alt plus X, select this command, and now we need to specify the mirror plane. In this case, I would like to get this circle on the other side of the y-axis. However, when I click on the y-axis, the mirror plane is created as if along the x-axis. In this case, we need to click on the x-axis. In this case, it doesn't matter whether we click on this side or this side. The mirror of this circle has been made from this side because we clicked on the x-axis. This defined the mirror plane passing through the y-axis, because if I drag this arrow, I am moving the position of this mirror plane, and the position of the circle also changes. Here, I returned to the value of 0 so that this plane passes through the y-axis. Regarding the mirror command, we will return to this when mirroring 3D solids, and then these mirror planes will be more visible. Here I click OK, and now I would like to get these two circles in these corners. Therefore, I hold down the Shift key and select these circles. I choose the mirror command again, and now I click on the gizmo overlapping with the y-axis so that the mirror plane is the plane passing through the x-axis. Click OK, and we have created additional circles. What you can notice is that additional elements have appeared here, and this is a list of elements of this project. Here we have the Curves tab, and these are simply 2D geometries. We have the geometry of the rectangle and the geometry of the circles. We also have an eye icon, and by clicking on this icon, we can toggle the visibility of the geometry. In this case, we will leave all geometries visible, and we have created such a simple shape. Now, based on these geometries, we will create a rectangle with 4 holes. Here, as you can see, I have area selection active, so I can select the area of the rectangle. I would like to get a box with holes, so I only select the area of the rectangle. I do not select the area of the circles, and automatically the extrude command has been activated. This command allows you to pull flat geometry and create a 3D solid based on flat geometry. Now, if we grab this gizmo with the left mouse button and drag it up or down, a solid will be created. Here it's worth noting the commands that appear in the lower right corner. These are commands that can be helpful during the current operation. In this case, I would like to add an extrusion to a specific value, and I can use the keyboard shortcut D here. If I press D, I can enter the extrusion value. I will enter, for example, 15, and the extrusion of 15 millimeters will be added. We can also specify the extrusion value here. To confirm this, we click OK or press Enter on the keyboard. In this way, we have created the first 3D solid. At first, we created flat 2D geometries and used the extrude operation to add the extrusion of flat geometry to obtain a 3D model. The geometries that we used to create this solid are not linked to this solid at all. Now, I will turn off the visibility of this solid and change the dimensions of the rectangle. That is, I select the rectangle, press the equal sign on the keyboard, and here I will type 100 by 150. Hit Enter. The dimensions of this rectangle have been changed. However, now when I turn on the visibility of the solid, this solid is already independent of these geometries. Once we have created a solid based on flat geometries, the solid is not linked to these geometries. Of course, based on these geometries, if we want, we can create a new solid. We do this in the same way. The extrude command has been selected by default. If this command had not been automatically selected, I will now press Escape and we can select this command from the list of commands. So I press the F key on the keyboard and here I type extrude, or we can simply press the E key. I pressed the E key and this command has been selected. For default commands to be automatically selected, there is an option in the menu. I will go to the menu to Preferences. Here in the General section, we have the option for automatically activating selected commands based on the specified geometry. I have it checked here, so when selecting a geometry, the command that is most often used after selecting a particular type of geometry is activated by default. Regarding this 2D geometry, based on this 2D geometry, we can create another solid. I click OK, and here, as you can see, we have two geometries on the list, two solids, and these two solids are independent solids. Each of these solids is a separate model that was created based on flat 2D geometries. For now, we will leave it like this. We will end this lesson here, and in the next lesson, we will continue working with this file. So save the changes to this file, and we will move on to the next lesson. In this lesson, we continue working on this project, and I will show you more basic issues related to creating 3D models in Plasticity. We will move on to different geometry selection modes. So, the first mode is selecting vertices. Here, as you can see on the solids, we do not have any vertices, but flat geometries are also visible, and on flat geometries, those vertices are visible. I will turn off the visibility of the solids, and now I can select, for example, this vertex. And here by default no command is activated, but when it comes to vertices on flat geometries, we can, for example, add a chamfer or a fillet here. This command is located in the command list under the name fillet, or we can invoke it by pressing the letter B on the keyboard. If you choose this command, you can add a chamfer or a fillet here, depending on which direction you drag this gizmo. We can also press D to specify the radius dimension, or C to specify the chamfer dimension. We can do this by dragging to create a fillet or chamfer here. And here we define the size of the chamfer or fillet, or as I mentioned, we can press D, type in 5, hit Enter, Enter again, and we have a fillet with a radius of 5 millimeters here. Similarly, we can also add chamfers and fillets on solids. Here, as I mentioned in the previous lesson, these flat geometries are no longer linked to the solids, so the changes we made in the rectangle will not be visible on the solids. I will enable the visibility of these solids, and now we will move on to selecting edges. Now we can select edges on the model. If you want to select multiple edges, do this with the Control key. You can also notice that we have hidden edges visible, and this is due to the X-ray mode. If I turn this off, those edges will not be visible. In many cases, this is useful, because in such a view, we can even select that edge. To select multiple edges, we do this with the Shift key. I press the Shift key, and sequentially select the edges. Now notice that I can select that edge even though it is seemingly invisible in this view. I select this edge, and here, in the case of selecting edges on the solid, the Fillet command is selected by default, which allows adding a fillet or chamfer. Similarly to flat geometry, depending on which direction I drag this gizmo, a chamfer or fillet will be added here. Let's add a chamfer with a dimension of 5 mm here. In this case as well, we can specify the chamfer dimension. I press C5 enter, and that chamfer has been added. Press enter to confirm it. Next we have the face selection mode. Here on the solids we can select faces, and if we have flat geometries, we select an area within a single closed geometry. Here I clicked on that face, and the offset face command was activated. This command works in such a way that now, by dragging this gizmo, I can extrude this solid. In this case, I can change the height of this solid. We also have a command under the letter D, which allows us to add this extrusion to a specific value. I press D, type in 10, and an extrusion of 10 mm has been added. In this way, the entire solid has been increased by 10 mm. We have simply increased this solid by 10 mm, and now click OK to accept it, and the solid looks like this. Next we have the selection of entire solids. Now I can select individual solids. In this case we have two solids, so I can select one, I can select the other, and I can activate some command that will work on the selected solid. If we would like to select more than one solid in the workspace, we do this with the Shift key. I press the Shift key, and I can select more than one solid. Such solids and geometries can also be selected here on this geometry list. Selection works as if we were selecting it in other places in the system. For example, regarding the Windows system, it works as if we were selecting files in a folder. Here we do it with the Control key, because if we press the Shift key, the geometries between the first and the last specified geometry will be selected. I select this geometry, press the Shift key, and for example, select this geometry. All geometries from the first to the last have been selected. If we want to select only 2 chosen geometries or 3 chosen ones, we do this with the Control key. In this list of geometry, we can also select solids or geometry, and this selection will also have a reflection in the workspace. In this case, these are 2 separate solids. However, based on these solids, we can create one single solid. Boolean operations are responsible for this. There is a Boolean command that we can invoke by pressing the letter Q on the keyboard or by clicking this icon. We have basic operations: union, difference, and intersection. If we want to combine these 2 solids, we choose the union operation or press the letter Q on the keyboard. We click OK, and now a single solid has been created from these 2 solids. In this lesson, you learned some basic but very useful issues. I am specifically showing this on a simple example so that it is clear how these operations work. We will finish this lesson here, but in the next lesson, we will continue working on this project, so save your changes, and let's move on to the next lesson. In this lesson, we continue working with this project. If you closed Plasticity, you may have noticed that when you start Plasticity, it loads in the state in which you closed it. If I closed Plasticity with this file, Plasticity will also open with this file. Here I will tell you about one more interesting thing. If, for example, you zoom out too much or zoom in too much, you can use this icon, and then the project will be centered in the workspace. If you have, for example, several elements, I will create a second element. Okay, now I selected this element and pressed this button. It will enlarge the selected element. If nothing is selected, the entire project will be shown so that all elements fit into the workspace. As for solids, we can remove such solids easily. We simply select them and press the delete key to remove the solid. Now we will add fillets to the corners of this solid. Switch to edge selection. Click here or press the 2 key on the keyboard. Select 4 edges with the Shift key. And here we will add a fillet. I remind you that we can do this by dragging or by typing a specific value. Here, what you may pay attention to is that we have grid snapping enabled every millimeter, and the radius values are defined in equal millimeters. If I turn this off now, the radius value changes even in thousandths of a millimeter. OK, here I press the D key, type 10, and press enter to confirm. This way, we added the radius. Now we will add a radius to these edges. We can select these edges with the Shift key, but we can also do something like this. We press the Alt key and click on this edge. Then, all edges that are kind of in one chain will be selected. Now to all of these edges we can add a radius or a chamfer, and let's add a radius of 5 millimeters here. I press D, 5, enter, enter again, and we have added a radius. If it turns out that we added the wrong radius, and we want to change the radius value, switch to face selection. I click the 3 key on the keyboard, select the radius, and we can change the radius value. Here, similar to edge selection, we can select it with the Shift key, or we can press the Alt key, then the entire radius will be selected. By dragging, we can increase or decrease this radius. We can also press the D key and type 2, hit enter. In this case, we specify an increase in radius by the entered value. Okay, we can leave it like that. And if you want to set a specific radius value, after clicking on the radius, information about the dimension of this radius appears here. It is 7 millimeters, and just by dragging it in one direction or the other, we can adjust it. We can also select the entire radius. Then we can press the X key on the keyboard, and this will remove the radius. Now I switch to edge selection. Again, with the Alt key, I click on this line to select the entire chain. Here, for example, I type D8, enter, enter again, and I have added a specific radius value of 8 millimeters. So, as you can see, even though this is not a parametric system, and we don't work with parameters here, we have quite a lot of options for dimension adjustments. The same situation applies to holes. Here we have the radius of this hole of 5 millimeters, meaning the diameter of this hole is 10 millimeters. If I wanted to change the diameter of this hole, I just need to press the equal sign on the keyboard. Here a value appears, but if now, for example, I type 5, hit enter, the diameter of this hole has been changed to 5 millimeters. So we select the hole, hit equal sign. For example, I will type here 7, hit enter, and the diameter of this hole has changed to 7 millimeters. Now we could do the same with the other holes, but we can also do it in such a way that we select all the holes with the Shift key and press the equal sign. Here we type, for example, 7, enter, and the diameter of all holes has been changed. Here I will revert to a value of 10 millimeters, so all holes are selected. I press the equal sign, type 10, hit enter, enter again, and we returned to holes with a diameter of 10 millimeters. Now in these holes, we will create counterbore holes. We can do this by creating additional circles. Select circle, drawing from the center. Now, when you hover over any circle, the snap will be activated because we have snapping enabled here. If I turn off this snapping, we do not have active snaps. Therefore, in my opinion, it is worth having this option enabled almost all the time. And now, when you hover over the center of the circle, we can create another circle in this spot. I press Tab, type 15, hit enter, and another circle has been created. We can create circles in the other holes in the same way, or we can use mirroring. However, in this case, it seems to me that drawing circles will be the fastest. We choose circle drawing. It is the keyboard shortcut Shift+C, so I press Shift+C and draw a circle. I select the center point, press Tab, 15, enter, Shift+C, center point, Tab, 15, enter, and we have created circles. We have created circles on the top face of this model, and based on these circles we will make counterbore holes. For this purpose I select 4 circles with the Shift key, and now we can add an extrusion downwards. I press D-5, and now if I leave it in that form and click OK, solids have been created here, I will turn off the visibility of these geometries. To turn off the visibility of several geometries at once, we can select these geometries from the geometry list. I select the first geometry, press Shift, click on the last one, and here I click on the eye icon. All selected geometries will be hidden. Now I will turn off the visibility of this solid. Here 4 such disks have been created. We could have created holes in this solid right during the creation of this extrusion. However, since we have created such solids, we can use a Boolean operation here. We will subtract these disks from the larger solid. For this purpose, we first select the first solid from which we will subtract, and then we select the solids that will be subtracted from this solid. We can do this by pressing the Control key on the keyboard and selecting individual elements. Or if there are more geometries, we first select the geometry from which we are subtracting the remaining geometries. Then we press the Shift key on the keyboard and select the last geometry so that all geometries, all solids, are selected. We choose the Boolean operation, and here the difference operation has been automatically selected. We click OK and we created such holes. We simply subtracted these disks from this solid. We could do something like that right when creating the extrusion. Now on this plane we will create another sketch. This plane can be a construction plane. If I have the face selected here, I press the spacebar and we will be switched to the construction plane view. Here let's create, for example, a rectangle measuring 75 by 40. OK, enter. We exit the construction plane view. We have this geometry. Now select this area and drag the arrow down. Here I type D-10. If we leave it like that, another rectangular prism will be created here. We also have the difference command. If I now press the W key on the keyboard, I can select the solid from which I will subtract this extrusion. We click on this solid to define that we will subtract this extrusion from this solid. We click OK, turn off the visibility of this area, and we have created something like this. As you can see, certain things in plasticity can be done in several different ways. In fact, it does not matter which method you use, because in the end, what counts is only the final result, not how we achieved that result. And we will finish this lesson here. Save your work progress and let's move on to the next lesson. The next interesting operation of creating 3D solids is extruding a profile along a path. Now we will create a sketch of the profile. We will create a polygon here. Select Drawing Polygons, and at the beginning we determine the center of the polygon. Place the center of the polygon at the origin of the coordinate system. By default a pentagon is created, but by holding the Shift key and rotating the mouse wheel, we can add or subtract the number of sides. Let's create a polygon here. If we press the Tab key, we can specify the diameter of the circle inscribed in this polygon. Let's enter 20 millimeters here. OK, we have that shape. Now we will create a path to extrude this polygon. Select Drawing a Line, and by the way, the keyboard shortcut for drawing a line is Shift+A. We press Shift-A and can draw a line. We will place the start of this line at the center of this polygon, that is, at the origin of the coordinate system. Now, we will draw a line along the z-axis. The dimension of this line does not matter much. Let's create a line approximately like this. At this moment, the dimension of this line does not matter. We are currently creating geometry of arbitrary dimensions. When it comes to drawing lines, by dragging the line appropriately, we can draw a line in another direction. For example, now we can draw a line along the y-axis. I will draw another segment of this line along the y-axis, and now I will draw another segment of this line along the x-axis. Okay, we have something like this. I right-click and now I would like to add fillets at these corners. I also press the mouse wheel to show how it looks. We have this 3D line. I switch to vertex selection and, while holding Shift, I select these 2 vertices. OK, I press the B key on the keyboard to add fillets here. Let's add the fillets. Now, regarding what I said about the dimensions of the lines, that they can be arbitrary dimensions. If this radius is too small, the operation I want to add may fail. I will set a small radius value here. OK, something like this. Now I switch back to area selection. select this area and choose the sweep operation. This is an operation that can be activated by the keyboard shortcut Shift plus P, but I click on this icon here. Now, as the path for extrusion, I select this line. Here, we cannot do this because by extruding this sketch along this profile, it would not be possible to create this solid at the places of these fillets. Something is just wrong here. We have information that this solid cannot be created, but it results from the fact that these fillets are too small, so I will cancel that and press Ctrl Z to return to sharp corners. Again, I switch to point selection mode. While holding Shift, I select those two corners. I press B key and add a larger radius here. Okay, something like this. Okay, now I switch back to area selection. Press the 3 key, select this area, and choose the sweep command. Now I select this line, and we have successfully performed the extrusion of this profile along this path. Click OK, and we have created a solid in this way. Here, if you select this solid, we can add another fragment of the solid, or we can shorten this solid by entering a specific value. We can lengthen or shorten this solid by a specific amount. For now, I press Escape key to cancel that, and we have created something like this. This can be a really useful and helpful function in many cases, but there may also be situations where we have such geometry to extrude a profile. I will create such geometry anywhere. For example, we will do it in such a way that I will start drawing this line here. I will draw a line along the x-axis, then along the z-axis, then in this direction, and then in another direction. I right-click to finish drawing this line. As for the sweep operation, the profile that we will extrude along the path must be perpendicular to the starting point of this path. In this case, to create such a profile that will be perpendicular to the path at this point or this point, we need to create a construction plane. We can do this easily. We just need to switch to vertex selection, select this vertex, and then press spacebar. Now, a temporary construction plane has been created that is perpendicular to the line at the specified point. Here, let's create a polygon whose center will be located at this point. Okay, let's do something like this. I rotate to show how it looks. I switch to area selection. And now, just like before, we select the area, choose the sweep command, select this geometry, and here we have created something like this. Here we didn't add any fillets, and the solid was created in this way. Okay, we have such solids. I will leave these solids here for now and create another geometry. I will also start drawing this line anywhere. Let's do something like this. Okay, we have such geometry. I will add fillets at the corners here. Okay, with the Shift key, I select these 3 corners, press the B key on the keyboard, and add a radius. Now I will show you another interesting operation because selecting an edge, it can be an edge created by these geometries, or it can be an edge on the model. We select this edge, we have a command here called pipe, we can activate it with the letter P. I choose this operation, and here pay attention to what happened. Automatically, based on this profile, a pipe has been created. This means this is a profile with a circular cross section, and we can increase the diameter of this profile. Here we also have a parameter where we can specify the number of vertices, and we can change this parameter. Here, the profile of this rod will change depending on what the number of vertices will be here. In this way, we can also create such solids. Here, I click OK, but as I mentioned, we can also select an edge of the model. I press the Alt key and select this edge. I press the P key. Here we can create something like this. By default, the operation selected is one that, based on the newly created geometry, will remove material from this solid. That works for me. I click OK, and we have easily created a groove along this edge here. So we point to the edge of the model, I press the Alt key, I select this edge, we press the P key. Here we can, for example, change the number of vertices, increase the dimension a bit. For example, instead of subtracting from this solid, we can press the Q key. The solid we are creating will be added to the previous solid. Okay, but we can also do it this way. We press the Alt key, select this line, then P. Here we increase the number of vertices to 3, increase the dimension a bit, and we can press the B key to create a new solid based on this extrusion. We click OK, and here a new solid has been created. These operations are very interesting, and in the case of conceptual modeling, they can be very useful. They can greatly facilitate and speed up the creation of 3D models. We will finish this lesson here and move on to the next lesson. In this lesson, I will show you another interesting operation, which will be extruding along profiles. I will start by creating two shapes in any location, for example, a circle and a rectangle. Here, I will choose to create a rectangle from the center. For now, you don't have to do this. You can just watch this part of the lesson. Now the rectangle is selected, and I will move this rectangle upwards. I press the G key, then Z to move only along the Z axis, type 75, and then press Enter. I click OK, and now we have two such geometries. Now, I hold the Shift key to select the circle, and then I select the rectangle. An interesting operation is to perform an extrusion of this profile to this profile, smoothly changing the shape from a circle to a rectangle in the meantime. This is a loft operation, which can be activated by pressing the L key on the keyboard or by clicking this icon. I click here, and look what has been created. Click OK, and we have a simple extrusion from a circle to a rectangle. In the case of the loft operation, we can add more profiles like this. We don't have to do it in the way I did it in this example, that is, having one initial profile and one final profile, but we can also add several intermediate profiles here. Now, I will hide this solid and hide this geometry. We will create several circles with their centers located at the origin of the coordinate system. First, a circle with a diameter of 50 millimeters. Then a circle with a diameter of 80 millimeters, and then a circle with a diameter of 40 millimeters. Okay, now we select the largest circle, press G to activate the move command, then Z and move it up by 50 millimeters. Hit Enter to confirm, hit Enter to finish this command. Next, we select the smallest circle. Again hit G, Z100 to move it up by 100 millimeters, hit Enter and Enter again. We have three such circles. Next, with the Shift key, I select the three areas of these circles and press the L key on the keyboard to create something like this. I click OK, and we have created such a solid. I deliberately created such a fairly simple shape because in this example I would like to show you two more interesting features. The first one is the Ispoparam command. I press the F key on the keyboard to bring up the command list, and here I type Ispoparam. We can activate this command using the shortcut control +R. We select this command, and now, as you hover over the surface, we can create such lines. If we press the Tab key, we can change the direction of these lines. Here I will go back to that direction and create such a line. For example, right here. I just click the left mouse button to create such a line. Okay, I have a line created here. Now I select this line. I remind you that if you have trouble selecting a specific geometry, you can simply switch to selected geometry selection mode, and in this case, you should select edge selection mode. Now I press the P key on the keyboard. This is the letter that activates the pipe command. which we learned about in the previous lesson. Here we can slightly increase the diameter. For example, I will type D2, and I would like to get a new solid based on this, so I press B and click OK. We have created something like this, and I wanted to get a new solid to extend this sweep a bit so that it goes beyond this solid. I click OK, and I will do the same from the bottom. I select this face and drag it a bit. I click OK. Alright, we have something like this. Now, based on this solid, we will create a radial array. Select the radial array command and place the center of the radial array here. Here we can increase the number of elements. We can do something like this, and now, for example, if we accept this, we can combine all the solids into one solid. Let's add a few less of these elements. Let's decrease it a bit more. Let's make, for example, 20 elements. And click OK. A lot of these solids have been created here. Now, if I deselect this and later want to add a Boolean operation, in this case, I could still easily select these solids because I would like to subtract all the solids that we now created from that large solid. First, I select the solid from which I want to subtract, and then I select the other solids. However, sometimes grouping such elements into folders can be a better solution. We can also do that. We simply select the elements that we want to move to one folder and click this button here. A folder has been created based on these elements, and now I just need to click on this group of elements in this folder, and all the elements will be selected. I would like to subtract these elements from this solid, so I select this solid, simply click here with the left mouse button, and then press the Control key and select these solids. I just click here on the group of elements in this folder. Now, with the cursor in this position and pressing the Q key, I can't activate the Boolean command. But if I move the cursor to the workspace and press Q, I can activate the Boolean command. As I mentioned, I would like to subtract the smaller solids from the larger solid. Here, the operation of subtracting one solid from another is selected by default. So I click OK, and we have created something like this. Now, I will show you another interesting thing. Select this face, choose area selection here, and we have the hollow a solid command. Select this command, and this command allows for the creation of a thin walled element, which means we can remove this top face, and based on this solid, we can create a solid with specific wall thickness. For example, I will type 1 mm here, and let's wait a moment for it to calculate. Okay, this value may be too small, so I will type 2 mm. And okay, something like this has been created, and the wall thickness has been created on the outside. That's not exactly what I wanted, so I will type -2 mm here. I click above this field, and we have the wall thickness created inwards. We have something like this created here. I click OK. I will also turn off the X-ray mode, and we have created such a solid. Regarding the hollow solid operation, I will create a cuboid here and select this face. I choose hollow solid, and here I can create an element with walls of a specific thickness. By entering positive values, we specify the wall thickness on the outside, and by entering negative values, we specify the wall thickness inwards. If I type, for example, -1 mm here, a box with walls that will have a thickness of 1 mm will be created, and if, for example, we wanted to remove a few walls, we simply have to select those walls. Here, I will also create a chamfer, and for example, I would like to remove this face and that face. So, holding the Shift key, I select these faces, choose the hollow solid operation, and specify the wall thickness that is to remain. This is a very useful tool in situations where we want to create such elements. We don't have to combine it by, for example, creating two elements and then subtracting one element from the other to achieve an element with thin walls. We can simply use the hollow solid command, and by combining this command with, for example, the loft command, we can get quite interesting shapes. We will finish this lesson and move on to the next lesson. In this lesson, I will show you another useful operation. I have already demonstrated this operation in the case of flat geometry, and it is the mirror operation. In this lesson, I will show you this with the example of solids. I will create a box here. The dimensions at this moment do not matter much. On this face, I will create a hole. We can also do it in such a way that, for example, we create a cylinder here. I selected the command to draw a cylinder, and I place the center of the cylinder in this spot. I specify some diameter of the cylinder and add an extrusion through the entire solid. I click here with the left mouse button and right click to confirm it. In this way, a hole has been automatically created here. Now I select the Create Cylinder command again. Here I specify the center of this cylinder, specify the diameter, and gently drag it inwards. Right click to confirm. And this way, we have a simple solid. Now, on this solid, I will show you how the mirror operation works. We have this solid selected. If this solid is not selected, go to the solid selection and select this solid or select this solid from the elements list. Select the mirror operation. We can activate this operation by pressing the keyboard shortcut Alt+X. We select this operation, and now we need to specify the mirror plane. Here we have a few keyboard shortcuts. We can specify this plane in such a way that the plane will be perpendicular to the x-axis, which means it will be along the y-axis. The idea is that along the x-axis, we will be able to control the position of this plane. If I now press the X key or, for example, click on this thing, the plane is positioned this way. By dragging the arrow along the x-axis, we change the position of this plane. If I now press Y, the plane has changed to a plane passing through the x-axis, but we control the position of this plane along the y-axis. Here I have to grab the arrow, and it's not always easy to do in every view. But okay, we have the arrow and we can change the position of this plane. Okay, I press X again to create the mirror plane this way. Here, the mirror of this solid has simply been performed in relation to this plane. I click OK, and we have two solids created here. When it comes to mirror operation, it is not very often that we want to perform this mirror feature relative to one of the default mirror planes regarding those planes that we can easily specify. By selecting the mirror command, we also have something like freestyle. By clicking the letter F, we can define the mirror plane ourselves. For example, now I will select the center point of this solid and then the center point of this solid. The mirror plane passes as if through the center of this solid because here I defined the first point and the second point. The plane is generated along the line I specified. As you can see, we have the union command, which allows joining the result of the mirror operation. If I press Q and accept it with the right click, we have something like this. This solid was simply made in such a way that we mirrored this solid relative to a plane passing through the center of this solid. Then we combined these solids and got a solid in which this larger hole is also on this side. Something like this may be more useful. When it comes to adding a mirror feature and defining your own mirror plane, we can actually place this plane anywhere. Now I press the F key and will specify, for example, 2 mirror points. I accept, and now this mirror operation has been performed this way. However, more often we will perform this mirrored feature relative to some characteristic points of geometry. I press F again, and for example, we will define this point and this point. I accept, and we have a solid created this way. Here I did not press the Q key, and these solids were not connected. We can combine these solids using the Boolean operation. When it comes to mirror operation, now I will select these two solids. We can add a mirrored feature. I press Alt-X, here hit F, and for example, relative to this and this point. Here I press Q, and those solids created as a result of the mirrored feature have been merged with the original solids. Mirror operation can be very useful in some cases and can significantly speed up creating geometry. We will finish this lesson here and move on to the next lesson. The next useful operations can be the rectangular array operation and the radial array operation. These are operations that easily create subsequent instances of selected elements in a specific manner. Regarding the rectangular array, it works in such a way that we can create a copy of the selected element along one direction and along the other direction. I will create a simple cylinder at the origin of the coordinate system with any dimensions. As for the rectangular array, it works in such a way that we select the element or elements we want to repeat in this rectangular array. Select the rectangular array command, and now we specify the direction in which these elements will be repeated. For example, here we will repeat these elements along the x-axis. Note that at this moment a construction line has appeared, and these elements will be created along the x-axis. If I click on the x-axis, they will be created along the x-axis, but also a bit downwards. Here, you just need to pay attention to where you click. I click in this place and have added 8 elements because here we specify the number of elements at a distance of 177 millimeters. We can change this distance now. For example, I just typed 200 millimeters. This distance of 200 millimeters is the distance from the center of this cylinder to the center of this cylinder. In this direction, the length of the array is 200 millimeters, meaning the distance from the center of this cylinder to the center of this cylinder is 200 millimeters. In this direction, we have 9 copies of this cylinder. We can do something similar in the other direction. We click here to select endpoint 2 and specify the second direction of the rectangular array. We can also define this direction arbitrarily, and we need to pay attention to where we click. For example, I would like to repeat these elements in that direction, so I click in this place. Here, notice that there is also this construction line. I click, and I have created a rectangular array of these elements. In the second direction, we also specify the number of occurrences, but this time all elements created in the first direction are repeated. Here we can also specify the distance of the array in the second direction, and we have such an array of elements. When we click OK, notice that all solids have appeared in the list of elements. If any solid is not needed, you can simply remove that solid from this array. This is how the rectangular array works. Of course, the solids created in this way can be used for other operations. For example, we can create a box here. We will create something like this. From this box, we can, for example, cut out these holes. So here in the list of solids, I select the box, press the Shift key, and select the first solid and last one, so that all these solids are selected. I press Q, and here the difference operation is selected by default. I click OK, and we have created something like this. Of course, we can also get this by creating a rectangular array of flat geometries, but at this stage we can also do it. I will press Ctrl Z to return to that stage. As you can see, by creating these types of elements, the rectangular array can significantly speed up the creation of elements. Now I select all the geometries, press Delete, and we will now proceed to create a radial array. Similar to the previous example, I will create a cylinder. This time I will create this cylinder roughly here. As for the radial array, we also add a copy of the selected element, but this time we do it relative to the selected axis. Select the element, select the radial array command. Now we specify the center of the radial array. As you can see, I already have the number of elements specified here, 20 elements, and the preview shows what it will look like. I select this point as the center of the radial array, and 20 copies of this cylinder have been created relative to that point. I click OK, and we have something like this. Regarding arrays, we can create both radial and rectangular arrays based on several elements. Now, if I have these elements selected, I can add a rectangular array and pay attention to what it will look like. Here in the second direction, I enter one element so that it is more visible. And in the first direction, for example, 3 elements. In this way, we can add subsequent copies of the selected elements. A similar situation applies to the radial array. I will delete all these geometries, press delete, and for example, we will create a few simple shapes. Okay, now I select all geometries, select the radial array, select the origin of the coordinate system as the center of the array, and here, for example, 3 instances of such elements. I click OK, and this is how we can make it easier to create copies of selected elements. With these simple examples, I just wanted to show how the commands for the rectangular array and radial array work. We will finish this lesson here and move on to the next lesson. In this lesson, I will show you how to create text in Plasticity. When it comes to creating text, we have a command in the command list called text. Simply type the text here and select that command. As for the command list, I remind you that we can activate it anywhere. When we press the F key, the command list will be activated, and here we can type the text and then select that command. When this command is highlighted, we can press the Enter key, and that command will be selected. We define the text that we will place in the workspace. As for fonts, we can only use fonts that are available in Plasticity. I will add a few more characters here. Regarding the size, we define the size here. We can enlarge the text a bit and click OK. Based on what we typed, curves have been created here, but this text is very large. Notice how this text looks. Now I will choose to draw a line. I will start drawing a line from this point to that point. This line is about 40 millimeters long. If you would like to check exactly how it looks, you can hover over this point. If you press the Shift key now, you will see auxiliary lines, and here you can see that the height of this character is about 40 millimeters. Displaying these auxiliary lines is often useful when creating 2D geometry. The height of the character is 40 millimeters, and this is how we can create text. At this moment, I will delete this text. The text is selected, so I press delete and will create new text so that there are a few less characters here. I choose the text command and will simply type CAD here. I will set the character height to 20 millimeters. I click OK, and this way we have created something like this. Based on this geometry, we can create a 3D solid. However, in the case of the letter A, if you want to create a solid, we would have to select all these areas with the Shift key, and based on these areas, we could create a solid. I think in such situations, a better solution may be to trim unnecessary parts of the geometry. We have the trim command here, and we specify the geometry we want to trim. We already have one area based on which we can create a 3D solid. If we select the areas that we want to use to create the 3D solid with the Shift key, we can create such a solid. I select all the flat geometries, press H, and the flat geometries are hidden. Based on this geometry, we created the 3D text. Of course, now we can edit each letter separately. These are already separate independent solids. We can enlarge, shrink, move, and rotate these letters. We simply have complete freedom to operate on these letters, as they are already solids, and we can use operations for creating solids here. Okay, this is how we can create text. Now I will turn off these solids. I will create a box here. Just change the view a bit so that this box is formed in such a way that its base will be on the XY plane. I choose to create a box, define 2 points, set the height, and accept. Now I would like to create text on the face of this box. For example, we will do it on this face. I select this wall and press the spacebar to activate the temporary construction plane. Now I press F and type the text. I select the text creation, and here I will type CAD 3D. I will change the font to something like this. The character height, may I type here 0.015 and click OK. Now the text has been created, and I can, for example, use the move command. I press G and now we move this text relative to this reference point. I would like to place this point, which is currently the center of this text, in the center of this wall. We could do it in such a way that we move along the y-axis and the z-axis. This text is roughly placed in this spot. In many cases, that would be sufficient. But we can also use the freestyle command here. We press F to find the reference point relative to which we will move, and select the center of this wall as the reference point. Then we drag this point to this place. First, we define the reference point relative to which we are moving, and then we define the point to which we are moving. We click OK to confirm, exit the temporary plane view, and we have created text on the face. Based on this geometry, we can create a 3D solid. Just pay attention to the fact that right now curves are selected, not areas. When I select the extrude command, press the E key on the keyboard and accept it, it has been done in such a way that the extrusion was performed based on the curves. Here surfaces have been created. Plasticity defines this as sheets, and we have surfaces here, not solids. I press Ctrl Z to undo this. If we want to create a solid, we simply have to specify the areas based on which we will create such a solid. In this case, we can either create new solids, or we can press the Q key, then select the box, click OK, and this text has been merged with this box. When it comes to creating text in Plasticity, at this moment, the selection of fonts is quite limited. In fact, we only have a few fonts. When it comes to simply creating some text on solids, that will be completely sufficient. If you want to use other fonts, you have to approach it in a slightly different way, and I will show you that in the next lesson. In the previous lesson, I showed you how to create text in Plasticity. However, as I mentioned and as you noticed, we only have a few fonts to choose from here, and sometimes when creating models where we want to create some text, we need to use different fonts. At this moment, Plasticity does not allow for that. We cannot use any fonts other than those built into Plasticity, but we can approach this differently. In this lesson, I will show you how to do it. Consider this lesson as an additional lesson, because in this lesson, we will need to use different software. I will show you one solution on how we can approach this to use other fonts than those we have in Plasticity. In fact, there are more solutions, but here I would like to show you just a general principle. I will create a new Plasticity file, and now to create the text, I will use another software, specifically FreeCAD. FreeCAD is a free 3D CAD system developed under an open source license, so anyone can use it. In FreeCAD, we will create text and then save this text in a format that is supported by Plasticity. To create any text, we will do it in the draft module. Switch to the draft module here. Then create a new file. Let's switch to the XY plane, select top XY, and it will automatically set to the top view. Here we have the text command, but we will not use that command. We will use the shape from text command. Here we have a list of several commands we can use, but this command is also under this icon, or we can also find this command in the menu, in the drafting menu. Here we have the shape from text command. We select this command, and here we first define the text. We just enter the text here. I will enter as before, CAD 3D. Here we specify the height of the characters, for example 20 millimeters, and here we select the font file. We click this button, and in this case we can use system fonts, but we can also download some fonts in TTF format. We can copy these fonts to some folder, and we can select such a font. I choose the font, click OK, and here we specify the starting point of the text. I click the reset point button so that this point is at point X0, Y0, Z0, and click OK. We have created such text. I see that this text is a bit larger than I specified. I can go to the Model tab. Supposedly, the height of this character is 20 millimeters. This may be due to some other settings in the font, but it doesn't matter much because we can change the dimensions of this text. For example, now I will enter 15 here. Click somewhere next to it, And now this text is about 20 millimeters because the dimensions of this larger grid are 10 by 10 millimeters. Here, this text is about 2 grids, and we will leave it like this. Now, in order to be able to use this text in Plasticity, we will save this text in step format. Here in FreeCAD it is flat geometry. Of course, in FreeCAD we could immediately create a 3D model based on the text, and we could also export this model to Plasticity, but we will do it in a way that we export flat geometry. We select what we want to export. From the File menu, we choose Export. Then we specify the location and name of this file. We click Save and click OK. Now we go to Plasticity, and in Plasticity we choose Import from the menu. Then we select the file with the text. This file is saved in step format, and this format is supported by Plasticity. We click Open, and here we use the default settings. Click OK. In this way, we have created the text. Now, based on this text, we can create a 3D model, but in this case, if you select this surface and drag the arrow, this surface will simply be moved because it was imported as a surface. I press Escape key to cancel this. I select this surface and press E to add an extrusion. Based on the extrusion of this surface, we can create a solid. I press Ctrl Z to return to that moment. With the Shift key, I select the other surfaces. Press E, press D to enter, and based on this, we created text with a height of 2 millimeters. We have several solids here. Now we can apply various tools to these solids. We can move, rotate these solids simply to achieve what we want. Just here, it's also worth noting, although it doesn't matter much, that this solid is in a different folder than the other solids. If we wanted these solids to be in the same folder, we can simply drag this solid from one folder to another folder, and now all solids are in one folder. This is one way that allows for creating text with different fonts than those available in Plasticity. There are actually many more ways. The point is that we create the text in another software and save this text in a format supported by Plasticity. Many graphic programs allow for creating such text. We simply import such a file into Plasticity, and based on this file, we create that text. At this moment, this text is a separate, independent solid. If we wanted to move this text to, for example, a face of some solid, we can easily do that. I will show you this in the next lesson. In this lesson, I will show you how to move solids quite freely in Plasticity. First, I will turn off the visibility of all geometries and demonstrate this with a simple example. I select all geometries, press H on the keyboard, and create a simple example. I will create a box, something like this. Now I will add a chamfer. I press the key 2 to switch to edge selection, and here I will add the chamfer. Okay, I will create another solid. We will create a cylinder. And now I would like to place this cylinder on a selected face of this solid. To easily place this cylinder on this solid, we need to use the appropriate command. I will switch to solid selection. Select this cylinder and press the F key to search for the command place. I type in place and we have the place command, which we can activate with the keyboard shortcut Ctrl plus D. We select this command, and now we need to specify a reference point. I would like to position this cylinder such that the reference point will be the bottom face of this cylinder, so I hover over this point and click here. Note what happens when I hover over this face. The cylinder automatically changes its position and adjusts to this face, but at this moment is this cylinder facing inward. But if I press the letter F to toggle the selection, the cylinder will be directed this way. Now I click here, and the cylinder is now placed on this face. Right-click to confirm this, and the cylinder has been placed on this face. I can place additional cylinders in other locations. For example, I will place another cylinder in the middle of this face. I hover over this point, press F to toggle the selection, click the left mouse button, and the cylinder has been placed here. Here we also have a little arrow, and we can move it a bit if you need to. We can also hide it a bit deeper inside, right-click to confirm this, and we can place more cylinders. Just now, when I clicked right, the cylinder I'm moving is this cylinder, with the reference point set this way. This point is not on the bottom edge of this cylinder, so it will be placed in such a way that this cylinder will stick out a bit from this solid, or if I press F, it will be a bit hidden in this solid. Right-click to accept this, press Escape to finish this command. This is how we can move one solid in relation to another solid. Now I will turn off the visibility of these solids. I select these solids, press the H key, turn on the visibility of some letters, or turn on the visibility of all letters and create a new box here. Somewhat like this. Okay, I will also add a chamfer here. I switch to solid selection. I select all solids. We can do this using the selection box, meaning I just press the left mouse button and drag over the geometries I want to select. Now I activate the place command. I press the keyboard shortcut Ctrl D and specify the reference point. We will place this reference point roughly in the middle of the letter D on the bottom face of this letter. I click here. Now I can easily move this text onto this face. I accept. Then I can move this text onto this face. However, this was done in such a way that I press the F key and click here. I confirm this with the right mouse button. In a moment we will fix this. And we can also create this text in this place. I clicked F, clicked left to confirm it, and clicked right to finish. I press Escape to stop moving this text. Here, the text has been placed this way. Sometimes this can happen, but these are still separate solids. It's possible that if we had chosen a different reference point here, it would have been moved differently. However, we can also handle this in another way. With the Shift key, select these solids. I have solid selection active, I have these solids selected, and now I will use the rotate command. This is the rotate command, which we can activate by clicking this icon or just by pressing the R key on the keyboard. We select this command, and here, when we make a rotation, it will not be done exactly as we would like. We would have to rotate in two directions. Okay? However, this isn't quite what I'm aiming for. I press Escape key to cancel this. I press R again. Here we have the pivot command. I now press the V key and set the pivot to the center of this face. I clicked here, and now I can add a rotation of 180 degrees in this direction. Okay, I accept this. Again RV to set the pivot, select the center of this face, and now 180 in this direction. And click OK. Now we have created something like this. I select these letters again. Now I press the Move command, which is G. Here similarly I press V, find this reference point, and now I want to place this text on this face. Although here a better reference point would be the point at the bottom of this face, so I press V again and select this point. Now I grab the Z-axis and I would like to place this point perfectly on this face. I press the Control key, and now, if I drag gently downwards, the snap would be activated here. I release the left mouse button, release the Control key, and we have moved this in this way. I click OK, and we have placed this text on this face in this way. Of course, it's possible that by choosing a different reference point, we would have placed this text immediately in that form, but this was a good opportunity to show you how moving and rotating works. This was also a good opportunity to show that not everything goes as we expected right away, and sometimes we just need to experiment a bit. We will finish here. I assume that when it comes to moving and rotating geometries in the way I demonstrated, it may not yet be entirely clear. However, if you do a few examples on your own, if you use these commands a few times independently, I think everything will become clear. We will finish here and move on to the next lesson. In this lesson, I will show you how to export a model created in Plasticity to STL and STEP formats. Regarding the STL format, this format is commonly used, among others, in 3D printing, but 3D graphic software also uses this format. As for the STEP format, this format can also be used for 3D printing, but it is also widely used in CAD/CAM systems. When creating models in Plasticity, we can export them to either STL or STEP format, allowing us to collaborate with other people, other graphic programs, or other CAD/CAM software. Here, I will create a cylinder. Select the cylinder creation option and create a cylinder of any dimensions. We will also use the hollow command to create this cylinder approximately like this. I click OK. Let's add some rounding to the lower edge. Also with any radius, just to have a radius here. Okay, we have this model. I am intentionally doing this on a round model where there will be circles. Let's create another cylinder. This time we will simply make a regular cylinder. Okay, we will leave it like this, and now we will export these models to STL format. To do this, we select the export option from the menu, specify the location where we will save this model. I will name it STL. We have here the available formats in which we can export the files. I am selecting STL and clicking Save. The export data appears, and the most important parameter is density. If this model, for example, will be printed on a 3D printer, I suggest setting the value to 1. Notice how the mesh of triangles changed. I click OK, and these models have been exported to an STL file. Now I will launch Prusa Slicer. This is the software in which we prepare programs for 3D printers based on STEP or STL files. I will import this STL file into this software. Okay, I am adding these files here. This is how it looks. Notice that these cylinders are almost round. Everything is smooth here, and when preparing the print based on these files, the prints will look quite good. Why did I pay attention to the density parameter? Because now, when we export these models to STL format, I will name it STL1. Now I will set the density parameter to a lower value. Here, I will set it, for example, to 0.1. I click OK. Now I will import these models into Prusa Slicer. These are the new models. Notice the difference between these models. Now these models are very angular and not as accurate as the models for which we set a fairly high mesh density. If you are preparing models for 3D printing, I suggest using a higher mesh density. In general, if you are preparing models for use in other programs, if you care about accuracy, you should also pay attention to mesh density. Now I will return to Plasticity. I will select this model only. I choose Export and name it STL2. Notice that only the selected model will be exported. Here I am increasing the mesh density. This density is set only for one model. At the time of exporting to STL format, only one solid was selected, and only that solid will be exported. Even though we have more solids available in the project, only the selected one will be exported. I thought this is also important information, especially in situations where you will be creating projects consisting of many models. Such situations may arise where you need to export only one solid. This is how we can do it. I click OK, and now I will load this solid into Prusa Slicer. Only this one solid has been loaded. Here we can also compare how the mesh density looks and how these solids look. Now I will move it a bit. Okay, and I return to Plasticity. I will now export both these solids to STEP format. To do this, we do it just like in the case of the STL format. We simply select Export and specify the format and name of the file. Here we select the STEP file format. I choose the default AP203 format, but I suggest you familiarize yourself with the other formats, as they differ in the information transferred. I will choose this AP203 format. Click OK. The models have been saved to a STEP file. Regarding preparing programs for 3D printers, we can also prepare such programs based on STEP files. Now I will load these models into Prusa Slicer. As you can see, these models have been imported exactly in the form in which they were modeled in Plasticity. We did not have to specify any tolerance or accuracy. We simply created circles in Plasticity, and here they have been imported as circles. We have the highest accuracy of the STL file, where we had to specify it ourselves for the file to be accurate, and here we simply exported it in step format. We have a perfect circle. Here it also looks like a perfect circle, but it is not exactly a perfect circle because STL files consist of a mesh of triangles, and this circle is not entirely a smooth circle. It consists of short segments, while here we have a smooth circle. More and more slicers, in which we prepare programs for 3D printers, support step files. So, if you have the opportunity, I think preparing programs for 3D printers based on step files will be a better solution. As for the step format, it is also widely used in CAD/CAM systems. It is a universal data exchange format between CAD/CAM systems, and we can use such a file in another program. I will now launch FreeCAD. FreeCAD is a free 3D CAD system, and 3D models created in Plasticity can be imported into FreeCAD. Here we start a new project, select File, Import. We specify the step file. Okay, this file has been loaded into FreeCAD. We have here the solids that we created in Plasticity. We have them now in FreeCAD, and in FreeCAD we can, for example, make further modifications. The situation looks similar in the other direction. We can create a model in FreeCAD, export that model to step format, and we can load it into Plasticity. Then in Plasticity we can work on that project. So as you can see, regarding Plasticity and collaboration with other programs, we have quite a lot of possibilities. Thanks for watching. I hope it was helpful and that you are now able to create simple 3D models on your own. Remember, with the code DamianCADCAM, you can buy Plasticity at a 10% discount. And if you want to support the channel's development, please provide your support on the Ko-fi portal, and you can find more tutorials on the Start 3D Modeling channel. Please subscribe to this channel.